a university where future is driven by imagination. Experiential learning creates diverse opportunities, where industry exposure and international partnerships help you sail. Come, start your journey to.
There's a place where the best minds come together, work to end inequalities, work towards transforming lives. This is a place recognized as one of the world's best universities. This is Amrita, now ranked among the top 100 universities in the world and ranked number 1 in India. Amrita University.
Amrita Vidyapeetham is one of India's premier top-ranked universities, which focuses on transforming lives through learning, research, and innovation. The university was established 19 years ago in the year 2003 and has made significant achievements in a short time. Education for life, education for living. Amrita University is guided by the thoughtfulness of our Chancellor, Amma, who laid down the philosophy of education for life by placing equal stress on education for a living. It is this vision that led to the establishment of a vast network of educational institutions that provide modern education while imparting the traditional values. While the pursuit of academic excellence forms the core of Amrita's success, it also undertakes the responsibility to shape the whole character of youngsters with love, care, and compassion. The university is headquartered at the foothills of the Western Ghats in Coimbatore, Tamil Nadu, and has 5 other campuses spread across South India in Amritapuri, Kerala, Kochi, Kerala, Bengaluru, Karnataka, Chennai, Tamil Nadu, and Mysore, Karnataka. The university will soon launch its new campuses in Amravati, Andhra Pradesh, Faridabad, Delhi, NCR. Our inspiration, a renowned humanitarian leader and spiritual leader, Amma is the Chancellor and guiding light of Amrita Vidyapeetham. Amma's concept of education, stress on research, and commitment to instilling universal values have come together to shape Amrita into an institution where the latest achievements and discoveries combined with compassion and service-mindedness. As Amma said in 2010, when the State University of New York presented her with an honorary doctorate in humane letters. Rankings. The multi-campus, multidisciplinary research establishment is ranked as 5th best university in India 2021 by National Institutional Ranking Framework, NIRF. We have also been accorded the status of Institute of Eminence, IOE, by the Ministry of Education, Government of India. A testament to our pursuit of excellence is the NAC A++ accreditation score, the highest possible. NAC accreditation measures universities for excellence in curricular aspects, teaching, learning and evaluation, research, innovations and extension, infrastructure and learning resources, student support and progression, governance, leadership and management, institutional values and best practices, global impact and international collaborations. Among the private educational institutions in the country, Amrita has entered into MOUs and collaborations with more than 450 leading universities around the globe. Students also benefit from our relations with industries and interactions with top management of multinational companies.
So, very good evening, one and all. Welcome to the Saturday series. Today's topic is about cosmology, the story of the universe. To all the participants and the cosmology enthusiasts, who wants to indulge themselves to the topic of cosmology, you have to think billions of years backward. How long can humans think backward? Your childhood? No. The great grandfathers where there was no electricity? No. We have to think backward from the formation of the first Homo sapiens in Africa. Yes, we are talking of 13.8 billion years. 13.8 billion years is the critical number. The era of hot Big Bang theory is where we have to start thinking from. And that's the beauty of cosmology. Then how can we forget the famous legendary scientists who have greatly contributed to the cosmology? We have Albert Einstein on the black hole, Stephen Hawking on the thesis of cosmology, Charles Darwin on the theory of Big Bang. But now we have a speaker, Dr. Bharat Kishore Sharma. He's going to enlighten us on the cosmology. Dr. Bharat has hands-on experience for 6 years at Tata Institute of Fundamental Research, Mumbai, University of Barcelona, Spain, CBES, Mumbai. So before we go into the session, if any of the participants have queries, please type it in the chat box. And over to you, Bharat, sir.
Thank you.
Thanks.
So, am I audible to everybody?
Yes, yes.
So, I'm going to talk about cosmology, the story of the universe. And you can see in this picture, there are a lot of astronomical objects. You can see it. So, we start the story as he's told that the story starts from the long back. So this is the picture. This is a simplified picture which is given by Nicholas Copernicus, and you can see it here. I hope you are able to see the sun here in the center. That is a sun, and if you can see it, there is a kind of a earth is there. If you have a small circle here, and then there is a simplified version. This is a part and the story of given from his book actually, which he gave it a long back, and you can see it's a very, very simplified picture of the universe. That sun is at the center, and then there are a lot of circular rings are there, and the stars are distributed here. And this is a picture, but in 1572, this picture will get changed. So I hope you are able to recognize. Is it possible that people can speak to me? Is it possible? Hello? Hello?
Sir, just 1 minute, sir. Could you just share the PPT?
This is PPT I'm sharing, no?
No, sir.
No, I'm sharing PPT actually. I'm sharing PPT.
Yes. Yes, that's it.
Just a second. I think you are there. That's right. So let me. So can people will speak to me directly, or I have to speak on?
Sir, you can speak, sir. You can speak, and
no, I need somebody
can
has
type the questions.
Yeah, if somebody in between can ask me, then it will be much better in case. Anyway.
Yes.
So now it's okay, right?
It's okay. It's okay.
Okay, fine. So this is a picture of the universe, and you can see many things are there. I hope you are able to, this is spiral galaxies, then there is a sun at the center, then there are some small galaxies in the right hand side. There is a Saturn also there. So this is the way one can do. It's an artistic picture. And when you can see it, we are able to show that the size of the universe has some finite range and strength is there. So this story start long back, and I started. So what I'm going to do in this talk, I will give you the basic features of the universe, our current understanding of the universe, and what is there in the future actually. So, and please feel free if you have any question, any doubt, you can interrupt me and we can discuss about it. That will be a much better session, because if I am talk only, then maybe something you have a queries, and maybe in later on we have a question answer session. So that time also you can discuss it. So this we start the story, and then you can see it's the top. It is written. It says something in Italian. This picture is taken from the book written by Nicholas Copernicus, and he is the one who gave the idea, who challenged that the sun is at the center and the other planets are moving around. So here you can see there are how many circles are there? 1, 2, 3, 4, 5, 6, and there are in the last one, which is called Sphera stellar fixers. So what it means is that the stars, there is this at the center, you can read it SOL, Sol. It is the symbol of the sun. And far from the sun, there are the stars, and they are fixed their position. They are not changing anything. This is the picture of the universe in the 16th century, when you don't have any exposure beyond the solar system. And then there are some stages are given here, 1, 2, 3, 4, like kind of a structure. If you're able to see, there is a small center, there is a white spot, you can see it. This is the representation of the earth, and there is some black spot there, that is the moon. So this is a nice picture. Keep it in mind that the stars are confined in a kind of a shell, and they are there and they are moving around the sun. This is the picture, the first picture of the universe given by Nicholas Copernicus. And this is, I am talking about the 60th century actually. Then in 1572 in London, there is a kind of a things happened, and there is a called some explosion happened in the sky. And what people will find it that there is a, in a daylight, they see the explosion. So it seems that either some new star created or the new star is died. So I hope all of you can understand that when you see in a telescope, the star which is coming close to you, it will appear bright, and when it is going far from, this is a daily experience also, you can see that if you have a distance and the object is far from you, it will appear less bright. That you can see, say for example, in the, if you are in the your terrace building and you can see the surroundings, you are able to see because of the distance whether they are close to you or far from you. But such kind of thing you can't apply for in terms of the stars, because when you see the sky, you can't say that this star is close to us or far to us, because it depends upon, you have to locate the things in the sky. It's not that simple. So usually basic idea is when the star appear brighter to you, you can say it's close, and then if it is dimmer, then you can say star is going away from. Something like that kind of picture people used to develop it, and this is a basic idea everybody should know about. But as I told you that when we, then 1572 in London, there is a explosion happened in a daylight, and people have no idea about it. Meaning is, if you take this picture which I have just shown it, what we assume that the stars are in their respective place and they are moving without creating any problem for other stars. But in this picture, what happened, if the star has to collide, is how it collision happened, and when they study its light, it becomes dimmer and dimmer. So what they find it, they change it, the basic change, if you can see in this picture, along with the color, the difference is, here your stars are bound to the concentric circle. Here, if you can see, the stars are going away. This is the first sign where people are put an idea that the universe is bigger than what you assume. Other picture, you can see there is no difference actually, except this last one, where the stars going away from. Now, if you're trying to get a feature how big the universe is, say big, large, huge, they are all small words. So if you're trying to get an idea that how, in terms of ratio, if you're trying to do. So for example, if you're trying to shrink the entire universe into the size of the earth, the size of the sun is shrink to the size of a dust particle. And earth is 100 times smaller than the dust sun. So you can assume if the sun is the size of the dust particle, how small the earth is. And if you are compare yourself to the earth, then you can understand how small you are compared to the entire universe. So this is a size ratio which people used to think about it and talk. So this is a simple picture and it is going on. So in 16th century, it is established that there are the stars, and because of that explosion, although people give the wrong explanation for that, they find it that the stars are not in a concentric circle, they are moving away with each other and they are colliding also. So this is a sign of that the stars and this universe is big and bigger. What we assume it is bigger than that. This is the importance of this picture actually. Now this picture remain the same and people trying to locate. I can give you a rough number of the stars also. You have some trillions of billions of stars, trillions if I tell it, 10 to the power 11 stars. So we have, I hope you people know about the galaxy also. There are 10 to the power 11 galaxy in one universe. And then there are 10 to the power 11 stars, each galaxy. So we are talking something beyond your imagination. And this is the most exciting feature. My last few years of teaching, I found it students are very fascinated about the cosmology. And when we come to end, you can find it. This is really a very, very interesting and remarkable story. Although I can put the title mysteries also, there is a mystery there, it is also there. So this is the way it will be. And you can see this is an old picture in the 16th century. Then with the, in later period, something 16 to 17 or 18th century, there are a lot of new things happened. First is Galileo developed its telescope, so you can see the far distance objects and all this thing. We saw the Jupiter first, so this is some kind of new planet. He find it, then he find it, what you call it, Saturn and so many planets. He discovered it, and then he find it something more than that. So the technology developed, and people are using his telescope will be improved by Newton, and he will give it a new telescope, and that you can see it much more. So in 1785, there is a astronomer named William Herschel. He are able to locate the idea that he able to find it the stars. So this picture will going further change. Here you can see there are something in written, and then the stars are there, some basic sun at the center, and the earth and moon, and some planets also not discovered that time. So there is some basic idea, but 200 years later, almost 200 years later, we are getting this kind of picture. So every point in this one, you can find it as the star, and sun is at the center actually. So this picture remains the same. But now this picture, which you can see it, we can put it the picture of our galaxy, which we call it as a Milky Way. And another advantage what we are getting is that the sun is not at the center of our galaxy. It is at the right hand side, what you can see. And how we can know, if you can see here, there are distribution of the stars. You can see left side and the right hand side. So there are the region, dark places you can see. This is the picture developed by William Herschel in 1785. So you can think it's almost so many years ago. So there are a lot of new discoveries happen, a lot of technological development, a lot of big telescopes are there, which you can explore. Now we are seeing the edges of the universe. So then if you can see it, there are more stars if you can discover it. So they find it that the stars you are getting right hand side of this picture more compared to the left hand side. And that's the way they can discover that, because gravity has a feature that it attracts everything towards its center. So they are able to find it that sun is not at the center, it is on the left side of the center, and it's moving also. So this is what the current picture is. But this is the one thing when you get the galaxy, but our main aim to understand the universe. So we are going to for the universe. So in a fast forward way, we start with 16th century, then we reach to the 18th century. And this is really not an easy task to find so many stars and their distribution. So there are a lot of astronomers. These are the some key ideas. That's what I'm telling. Otherwise, doing this one itself a thing. So this is our story up to the 18th century. Then 20th century is coming, and the whole world of physics get revolutionized by so many things, and it's a golden period of theoretical physics, observational thing. But the center stage mostly in terms of when you're dealing with physics related to the atoms. But parallelly, there is something going on, and then there is a certain observations there, and this is what people find it. So in 1920, there is a called astronomer whose name is Hubble, and he finds something very remarkable. What he finds it that the galaxy, this universe, when he established that there are 10 to the power 11 galaxies, he finds it that the universe is expanding. Actually, there is a story when Einstein gave his theory of general theory of relativity. So during his calculation, he finds it that universe is expanding. His theory will tell him that universe is expanding. But he talked to his astronomer friends, and they told it that according to them, universe is static. So universe will not expand anymore. So what he did it, he had some term in his calculation and put it. Later on, he regret for that. He's saying he did a blunder of his life actually, because his theory is saying. So this is called the expansion of the universe. So usually in the class, when we talk about the expansion, what we talk about it that, for example, you have a balloon, and there are 2 points mark on the balloon, and you can throw the air in the balloon, and when the balloon take it is bigger size, that points are coming far from each other. Although it's quite a good picture to explain some basic idea, but actual one is not like that, because the difference is in the balloon, you are throwing the air in. But in the galaxy, especially the universe, it's say one part of the universe you take it, it's expanding itself. There is no such thing which you are putting inside there. So this is the two picture you can see it. And keep it in mind that there's nothing you are pouring there. This is just a expansion is there for that. So galaxy do not move apart through the space. Rather, galaxy get further apart as the space expands. So what will be the cause of expanding of the universe? So this is the first feature which can give a trouble to many astrophysicists. Still, it's a kind of a question, but once I come to the actual slide, then you realize that this is not a big problem. There is a much bigger problem actually. So expansion, you can understand the size is just expanding. It's a basic physics idea that you have this box and its size will become bigger. It looks like that way. So keep it in mind that the space is expanding without putting anything inside that. There's nothing like that. But if something is there, we are not able to detect. So the next is, this is the thing which you can say, this is another example. So you have a rubber sheet and there are the coins are there on that center. And then you just scratch it, that rubber sheet. So the distance, they remain there wherever they are, but it appears to be. So as a rubber sheet is stretched, coins get further apart, even though they are not moving across the sheet. This is the basic idea. So this is a question of the expansion of the universe. And that you find it in 1920. Now the question is, if this is an expansion, will it continue further? Or when and where it is started? So most of the time, if you take your telescope and other thing and see the universe, what you find it, there are certain features you are able to see. But it's a very non-intuitive idea that if I told you that what you are seeing, it happened something 1,000 years ago. Because the light, the object is so huge and big, light will take something 10 to the, if you want to go from one side of the Milky Way to the other side, light will take 10 to the power 5 light years. So light travel in 1 second is something 3 into 10 to the power 8. And if light is taking 10 to the power 5 years to come from one side of the galaxy to the other. Now we have a lot of very powerful telescope. Recently one James Webb telescope is there. You are able to see it. Some few years ago, we have this black hole picture, 2019, just now. It's a very golden period in terms of observation side. Theoretically, we have a lot of ideas. So basic idea is that universe is expanding, and the question is when and where it started and what information we have. One way we are lucky that light will take that much time, so we can able to see what happened some 4,000 years ago. So when we talk about the age of the universe, is actually the evolution of the universe. So up to now, what I discuss about the observational fact, which can explain the evolution of the universe and the picture, which you can see it, how the universe is there. And it's a very important idea, the expansion of the universe. And I hope with these two slides, I'm able to convey how the space is expanding. Okay, and keep it in mind, it's just a one thing. We're going to do it much more. This is what observationally we can do. Whatever information we are getting in terms of electromagnetic wave. Light is one of the electromagnetic wave. So you can see it, there are this scale. RU means U is the universe, R is the size, radius, you can put it. And again, we are taking example of that sheet. So electromagnetic wave is coming from this blue and then 2 and 3. So this is a changing there. So bands on the rubber sheet is spread out as this sheet get stretched. So if you get stretch it, so wavelength is increasing. I hope all of you know what is the wavelength. Wavelength means if you take the two head point there, the distance between this point, which you call it it is start from the one full wave, if you can see it, which start from 0 and then it will go down at the last. Your crust and higher and the lower position in a wave, you can say it's a wavelength. So it will become bigger and bigger, and from that wave crust of the electromagnet is spread out as the universe extends. And this is the red shifting of the universe. So red shifting means if you take the observation, it will shift it toward the red side. And red means because red light has the higher wave. That's why all your symbols and this one gave it, because it not scattered the light. Even you can see in your lasers also. So this is another thing, how you can observe the expansion of the universe in terms of the theory, in terms of the observation. So this is what it's there. So let me summarize. We start with the basic picture, 16th century, then 17th century we reach, sorry, 18th century, 19th century, this is the idea people are getting. Now you have to improve your theories on the basis of that one. So this is what redshift light, you can see it. So this is a galaxy, a star in the Milky Way. You can see this is what it is there. And then this is a galaxy some 7,600 away it is going on. So these are the absorption lines, the dark lines, which you can see it. I'm not going to give any detail, but this is a meaning for that one. So absorption line in the spectrum of this are red shifted by galaxies motion away from us. So meaning is if this is the spectrum, there is a shift. So for example, there are certain lines are mentioned, okay, in the first figure and the second one. So there is a called H alpha, H beta, H gamma, H delta. This is a part of a spectroscopy. It's a very, very powerful tool for so many years. Not now, long back, the time of I think after Newton's 17th, 18th century, people have this spectroscopy. For example, if you have any object, you can burn it in chemistry actually. So it will give you the light. So that idea they can take it. And this signs are there because atom has a certain structure. So electron will jump and give it out. So here you can see the arrow, the top, and it will shift it. If you start it from the top slide to the bottom one, so there is a kind of a slightly shifted arrow. You can see it. This is blue color. It shifted to right hand side, and then this H gamma, H beta, and H alpha, or you can start with H alpha. So it is shifting from there. And this is the formula which you can find it, what you observe, what is at rest, and then you can find it the speed. So this is what it is telling, how you can find and expect the things. So this is an observational fact. The galaxy or stars or astronomical object, if they are redshifted, we can say that they are redshifted because of their going away and all this kind of things. So this is all sign of the expansion of the universe. So far, I am talking about the expansion. But there are many things are there. And then if you take a picture, so these are the certain galaxies, as you can see it, because a galaxy is a part of the universe. We are in the Milky Way. So this is some galaxies, Virgo, some air, all these things are there. And how it will appear, so you can estimate their sizes. There, I am not an expert in this field, especially the observation part, but you can see it, the expansion, which is this light part, you can able to assume it, that how it is speeding up, it will going away. So this is the fact that from the shifting, the previous slide which I show it, you can estimate what speed it is going. So if you take a observation for some long period of time, you are easily able to find it that how much it is speed going. So galaxy remain there and the universe is expanding. This is what the basic fact is. Now, because of that, this is what the theory will develop. You find it that the universe is expanding. So this is what you can see right now in the top. There are 3 stages, you can see it. You can take X and Y as your distance, and this is the arrow on top is the time. So we are going backward in the time. So this is our current position. It's an artistic picture which you can see, and then below, and then so you are at the bottom. There is a called singularity. In physics, singularity means you reach to a point where your theory not able to explain it. But if you assume that there is a singularity, I am come to this point, what is the meaning of this singularity and what is the role of that one? And this sign, I hope you all know, there is a called Big Bang. So there is an explosion happened, and then these galaxies are formed, and then they are moving away because the space is expanding. That is what people are doing. And trying to understand the universe, we have to understand the motion of the galaxy in the universe. So we started with the picture of the universe and then how this picture will change. Now we are in a 1920 and we get an idea that the space is expanding. Many people are worried about it, why it happened, what is the reason behind it, is there something which we are missing, which triggered the expansion. But the story will not end here. This is a small part. Basic idea is some people give a theory that there is some explosion happened and that it pushed the things. So there will be also a finite time. Means if there is an energy which can make you away, going away from the thing, so there will be a certain reason for that. After some time, it should be slow down and some observation. So this is the time of 1920s and later on I'm talking about. But in the same time, the great Edwin Hubble, he finded this. This is very interesting picture actually. And I hope you people have an idea how to plot the things. Don't worry if you don't understand what is this MPC. This is a distance, you can put it there. So basic idea is, if you remember, we have, before this slide, we have this all galaxies, a different form of galaxies. Some are elliptical, some are other kind of things. So you keep it, at least you remember the 1, 2 name, Virgo, Ursa Major, and all this thing, you can know it. So these are the galaxies, some names are there. And there are recession velocity. Recession means it is going away from, and this is the distance which you can calculate. The interesting part is the galaxy which is away from this Hydra. its speed is higher. If you're trying to make this black spot on that right top, Hydra, and if you go to the corresponding Y value, it is 60 into 10 to the power 3 kilometer per second. And from the center, it is farthest galaxy. So meaning is the object which is far from you, its speed is much higher compared to the object which is close to you. This is a straight line. These are the observation fact, especially these points which you can see it. This is recorded by Edwin Hubble, and there are some other astronomers from that Mount Wilson spectroscopy. This is the one of the telescope on the which is built on the Earth actually in California. It is some 100 centimeter. Now, see, telescope is like a bucket of where you can collect the light sources and other things. And Edwin Hubble is a very big, although he's not a physics student, he is a law and he's a basketball player, but he has a passion to see the stars. So astronomy is not for a person who know the physics, or you have to be a patience and passion both to study. So one of his discovery is that he find it, the galaxy from us, it is moving much faster compared to the close galaxies. And this is an open question from long time. Even now also, because in 1998, people think, so there is a term called, I hope when I come to that point, I will discuss about it. So for as of now, this not only the expansion, there is an acceleration. Expansion means the object will become bigger and bigger. It can go with a constant velocity also, but it is expanding with an accelerating rate. Acceleration is the sign of to explain this figure, that the object which is far from you is pushes much faster. And interesting part is, if you talk about the gravity is the only force which attract everything towards it. So what making this thing not only expanding or accelerating like this is still people are trying to find it, and they are finding some solution. I hope many of you have an idea about it, but anyway, if you don't have, we will discuss later on. So this is what the thing. So up to now, you have the picture of the universe is keep on changing from many ideas. And what we find it that universe is not only expanding, it's accelerating actually. And we have to find it what will be the reason for it. So it will challenging your intuitions, your knowledge, whatever you know, there will be something which is missing there, and that we have to find. So that time around 20s and 24, people are giving an idea. As I told you, the expansion of the universe is there, and one thought of school is thinking that there will be some explosion which create this expansion, this picture. And this singularity, which we call it, it's called by Big Bang. It's one of the finest nuclear physicists and astrophysicists, George Gamow. He gave the idea of the Big Bang theory. There is another theory is also there for universe, which is called steady state model, that there is no such explosion, something is formed and it is keep on changing over a period of time. But right now we have some observational proofs which will tell it that Big Bang theory is much accurate. So first so keep it in mind that Big Bang idea is that some explosion happened. Now the question is, which trigger this explosion? Will at the end of the universe, will be a explosion again? That kind of questions one has to find it answers. But if you say it, so these are the two models. Universe created from a dense permeable fireball that I have already told you. The steady state theory is telling that matter continuously created with the net constant density. Some object is formed and it is keep on forming. Now, when you propose a theory, you have to give their observational or experimental proof. So because we know that the Big Bang model is a one, so this is the predictions of the Big Bang theory. So as Hubble observed that the galaxies of the universe are moving away from each other at higher speed. So universe is apparently expanding with accelerated. So from some primordial event, This is the reason why people talk about the Big Bang. Now, this is an interesting story. When there is an explosion happen, there will be some kind of radiations. And that radiation will put it in the entire space. There are different sources of radiation from the sky you can get from heaven, people used to say. And there will be a source for that. So these two people, Penzias and Wilson, they find it the cosmic microwave background radiation, which will permeate the entire universe. Now, this is a very interesting and very lucky draw. These both Penzias and Wilson, they are engineers in IBM, and they've developed one telescope to study the radiation sources from the sky. And while doing this observation, they find it a very strange kind of radiation sky. And they are not able to explain its origin. They try their level best. There are a lot of interesting and funny explanations are there. For example, that radiation is created because of some fission will there and so many other things. At the same time, they are not aware of the fact that Big Bang theory predicts that there should be some radiation. If there is a Big Bang, you observationally has to find some radiation, and cosmic microwave background radiation is one of the proof of Big Bang theory. Accidentally, they got it, but they have no idea, and they published paper. It's a 1-page or 2-page paper, and they are the luckiest Nobel Prize in physics. They got it Nobel Prize for that particular paper. So what they find it that the entire universe is filled with cosmic microwave background radiation. This is one of the important subject observationally, theoretically, that we are able to understand how the universe is expanding, what will happen in the earlier stage and what happened to it. And the prediction of this abundances of all the elements and other things are found. The other theory of Big Bang model is one general relativity. I'm not going to talk about because technical detail, I'm not going to talk about it. And there is a cosmological principle, so which assume that the universe looks roughly the same everywhere in every direction. Meaning is you are any point of the universe, whether you are on the earth, moon, or any space, you find it there's no difference at all in describing. And he showed it, Friedman is another one who showed it, that originated in the explosion, which is a Big Bang. And if you take it universe isotropic or homogeneous. So if you take this idea, this is an observational fact, if you take it and write it a theory, what it will say that universe either expanding or contracting, it's not static. And that's where Einstein theory will predict it actually. But Einstein has an idea that it will be static. So he put it that term, and later on he regret that he did a blunder for that. But that is the idea. If you understand the universe, so there are two features, that universe is isotropic and homogeneous. At the same time, some kind of radiation will be detected, and they detect the radiation, and this is also there. So now entire focus shifted to study the cosmic microwave radiation, because if this radiation happened in the time of the formation of the universe, so a study of that one can give you a better idea what exactly happened that time. Although still there are certain questions about the whether there will be a Big Bang or Big Bang happened and other kind of things. So this is what Big Bang. So Big Bang theory explains the cooling of the universe from opaque to the transparent. So this you can see in the right hand side. And this is the picture of the universe. You can see it. This is, you are in something around, it says some latest picture, and the top you can see there is a called Cobe measurement. So this is cosmic observational, cosmic microwave, this explorer. I will talk about it. It give you the picture, and this is simple wavelength and frequency. You can find it. This is what earlier it is happened. You can see it. First, there are radiation. So in cosmology, if somebody will ask you what is the difference between the matter and radiation, so both they consider as a particle. And the particle which is moving with the speed of light. The speed of light means 3 into 10 to the power 8 meter per second. They constitute the radiation. And which is going lower than that, they are making the matter. Matter means every single thing which you can imagine or you can see it surrounding, even us, earth and all these things, they are call it considered as a matter. Physics is actually the study of matter and radiation and their interaction in different space-time, from space to the as small as the size of the nucleus or as big as the entire universe. So if you look at into the universe back in time, this is what this happened. Slowly, you are getting this one surface and Doppler shift of the radiation, that rate shifting, which you can say, will be highly redshifted because of the expansion. So universe expansion is an observational fact and you have to develop the theory. There is a theory called Big Bang, and Big Bang has the prediction that there will be a radiation which you can observe it. And this is nicely fitting data points you can see. Now our current study is based on to study for this one, isotropic and homogeneous universe, how it will look like. This is what it happened. So this is called early universe. The small temperature variation, you can see. So in the early universe, it's also a picture. So these are the some spot, you can see it here, green, here's some background. So this is the part of the universe and the radiation, because once Big Bang happened, this is the way it looked like. And over a period, it is changing. And these are the certain stage. And finally, what you are seeing in the right side, the last picture, the fifth one, that is what the picture, the universe looks like and clustered. I don't know how many of you know about the temperature part and other things. So if the color will decide whether temperature is low. So earlier it's a very high temperature and slowly it's going. So right now the temperature which is close to the, that's why you call it a microwave actually. So the temperature is something 3 degrees Celsius or 3 Kelvin actually you can say. Actual number is 2.79, some error there. So gravity acts as an initial perturbation. So you can see the matter has become more and more taking its shape over a period of time. This is the previous picture. This is the picture of that radiation, matter and the radiation is slowly becoming atoms in picture if you can see. And because in between there is a space is there, so this radiation will come out. So left hand side will tell that there is a radiation, then the atoms start forming. From atoms, the matter start forming and the radiation is going past through it. And why matter is because these particles are moving less speed compared to the light. That's why they constitute the electron is 98% to the speed of light. So around that particle, proton is more massive, so it is much slower. So these structures are formed. This is the early stages. And this is what the formation later on can get it in a large scale. This is what the picture is. So people are doing. So these are the 3 telescope, or say this is a spacecraft we launched to study. So there is a called COPE, WMAP and Planck. Planck is in 1989 or something. And these are the pictures. Hubble constant also, the way it is with the rate at which it is expanding, that you called a Hubble constant. And if you can see this picture, and these are the photos of those telescope, or sorry, the detectors which you can do it. The picture become more and more clear if you're going from. So COBE is a cosmic background explorer. So that's the way they named it, COBE. Sorry, I have some light cut here, but anyway, I hope this picture is correct. WMAP means some kind of structures you can see it, and the Planck, which is latest people find it. It will be much more better picture you can find. And these are the how the universe. So first you have a green color completely. Now it's not a green, it's some kind of structures you can do, and this is what the Planck. And these colors have some related to the temperature. Red one, I think it's the light temperature, others are higher temperature. This picture mostly you can see in most of the thing. And that is what you have done, you got it. So cosmic micro CMB, if you study, so now you can find it the percentage. And what the interesting part is, we know only the 5% or less than 5% of the matter. In last 500 of years of our physics, able to explain that one. There are some other features are also there. There is a dark matter, which is a part of our galaxy. And this dark energy, this is proposed in 1998 by Michael Turner, the name dark energy. So this is the energy which is responsible for the acceleration of the universe. Not only expanding, expanding is related to the Big Bang, acceleration. Because in 1998, people have an idea, cosmologists especially, that it will be slowed down. So curve, instead of going straight, it will go back, but it not happens. That is what they will think about it, that there will be something. And now this is what percentage of, you can see, and this is 13 billion years ago, what it really happened. So this is the new feature. So you are getting better and better results, 68% and much more better picture, but we know only the around 5%. You can see it in this some number 68.3. This is our latest number of percentage which you can. And this is what the picture of universe we have. You can see the right hand side. This is the time scale, 10 to the power minus 43 second. There is a Big Bang. And then there are different present 1 billion ago, how it looks like 500 years ago, just after 3 minutes in this all this second. And they have a name also, Planck era, jet era, nuclear era, atoms and all these things. So all kind of matter, radiation, how it will, this picture complete everything, whichever way you can see it. So we will take one by one. So first is the Planck era, 10 to the power minus 43 second. Our physics will not explain. So Big Bang happened and it happened up to that much time. So all knowns of physics break down and we cannot say anything about what condition were like. Then there is a period of 10 to the power minus 43 and minus 38. So this is called GUT era. This full form of GUT is Grand Unified Theory. So they will say that all the forces are same strength, means gravity is as strong as electromagnetic force or strong and weak forces, because the strong force is the strongest force which hold the proton together, but it's a short range. After that, from 38 to 10 to the power minus 10 seconds, there is a electro-weak era, weak interaction and electrons will be there. This is what you can see in the starting. And on top, you can see the temperature, how temperature is shifting from 10 to the power 32 Kelvin to 3 Kelvin. And this is the time which you can start it minus 43, 35 to around 10 to the power 6. So our recent accelerators able to find it, some basic features is about electromagnetic and weak force. These are the 4 fundamental forces. So before around 10 to the power 32, they are together, and after that they will shift it other side. So this is also one of the important, or say, Nobel Prize problem, to check it whether these forces are the same force earlier time and how we can detect it. Now particle era, as I told, the particle start forming. So you have a plasma, charged particle is moving, proton separate, electron separate, and then they make a hydrogen atom, then helium and all these things. So it form matter and antimatter. So there is another thing, maybe we will discuss about what antimatter means. If you have an electron, there is another kind of particle which has opposite charge, that is called antimatter. It is one of the matter of the, which you can say visible. This is all part of the 5%. I'm not talking about dark matter and dark energy. This is a part of 5% information, whatever we am telling, it is from that part. And there is unknown reasons, there is more matter than antimatter. And this is what the number is. Photons annihilate each other, means if matter will, this is another definition, if matter and antimatter combine together, it gives you the radiation. This is particle era. Then this pair production happens. This is the most famous equation in physics, E equal to mc square. If you have energy, so you can create the mass. If you have a mass, you can create the energy. This feature is responsible for this radiation is coming and give you electron, and this is called anti-electron. The names here given, it's a positron, it's the name. And if positron and electron will merge together, they can give you gamma ray photons, like that way. High temperature. So this is all from particle physics side we are getting. Then this nucleosynthesis process start, just like once the particle fix it, how they form the hydrogen or helium. Because if you map the universe sky, it's 75% visible matter, which you can detect it. Visible means not eye to, you have electromagnetic radiation from radio to X-rays. The detectable matter, if you take it, something 75% made of hydrogen, 25% helium, and then other elements are whatever the small portion. 75, not exactly, something less than 75 or 25, whatever with 2% or 0, something like elements are formed. Then this another structures are formed. That is what deuterium, the heavier isotope of hydrogen. So I am going slightly towards the nuclear physics side because I am a theoretical nuclear physicist. But one thing you realize that particle, nuclear, everything is combined. It's interdisciplinary research. You can't leave one subject. So if you are a cosmologist or you are interested to become a cosmologist, you have to be a good knowledge of other subject as well. So this is what the high temperature, how these heliums are formed in the core. This is what rough estimate is there. There's still people trying to understand that if in the sky there is an hydrogen and helium, then how on the earth we are getting 92 naturally occurring nuclei. There's so many things are there. Then this process happened between 3 minutes to 500,000 years. So it's a long time duration, and everything is formed. Once atoms are formed, hydrogen atom and all these things, it will settle it out. And this is what it will happen. So plasma of neutral atoms, it will cool down over a period of time. Then it becoming some clouds. And then all everything, planets, life, whatever we have. So this is a kind of a very fast forward way of telling the story. There are many things happening. There are very great giants, and still so many great physicists all around the world trying to find it. And in physics, there is a no the end. There is always 3 dot to be continued. So we reach to the level now on the basis of our understanding. I have not touched the part dark matter and dark energy because it needs some another side, and because there is a limited time for that. So I hope I am able to convey how this originate the universe and evolve. Now the big question is, under our current understanding, what future we are looking at? What is the theoretical prediction? And when I say future, it's not next year or 10 years or 20 years. I'm talking about some 10 to the power 5 years later, what will happen? And theory can predict it. So there are 2 predictions of the theory. One is this one, that universe will go expanding forever. It will never, and the universe will eventually die as the stars, galaxies reduce to the clouds of gas. So after expansion, and it reach to the point where it will be finish it off. There is another theory which is called Big Crunch. This will tell that the universe will expand up to certain point and it collapse back into the reversal of Big Bang. That thing, if you just put the reverse order, so it is written BIG BANG. So this is your Big Bang. If you reverse this one, you start with the small g, that is called Ganab, GNAB and GIV. So that situation is called Ganab. So at the end, it will be shrink, and then it will start the Big Bang and new universe. So I hope I able to convey in a short period of time the basic idea and other things. So I thank all of you for your kind patience. And if there is any question, we have still 5 minutes and we can discuss about it. Thank you.
Thank you, Bas, sir, for such a wonderful session. Sir, we have a few questions from our participants. First one is, sir, how does the red shift of the light obey the law of conservation of energy as the wavelength is changing? Where is the energy that is lost?
Energy is not lost actually, the electromagnetic radiation which you are getting. So energy is a corresponding thing with the radiation. So there is a frequency corresponding to that. So if the star is moving away, it will shift it actually. There is no loss of the energy, it's a shift actually. So shift means basic idea is that you have a light source and you can see the object, and if it is going far away, it will appear to be much dimmer, but you are doing very short distance. Now, if you have a star and you can see its energy, actually energy is thermal energy because luminosity is coming, you are observing. When you see after certain time, thermal energy remains the same, but the light which you are receiving, it become a red light. So what it means is that it is going away from. So there is a shift actually. So it is moving away. That is what the answer is. Energy will not lost. Energy is the same what a star is predicted. But because of the distance, for example, if you see the sun and you see the moon, for you it looks appear the same size. But sun and moon are not the same size. Because sun has some kind of bigger size. And how you know that? Because sun never disappears from the earth. When you see it, sun is there. But moon disappears. So this is the basic idea of an object, bigger object with the smaller one. It will be visible to you, but in coming in front, it will go and then again appear. So light will not, energy, what you are talking about, the luminosity remains the same, but it becomes dimmer because it's going away from. So this is an observational fact. See, hydrogen line is the same, but there is a shift there. I hope I will be able to convey the answer.
Sir, another question is that which reference book do you prefer to detail out this topic?
There are many books are there, very nice book, and their online sources. It depends upon what is the interest of the candidate. So usually I prefer one book called An Introduction of Astronomy and Cosmology by Ian Morrison. So Ian Morrison book is very nice pictures and all historical ideas are there. It is for if you have no idea about it, so you can get all. And Ian Morrison is one of the finest astronomers from Oxford University. Soft copy is also available. And maybe you can share my email ID to them. If they want it, I can send a soft copy and they can check.
Yes, sir. Sir, next question. What is the evidence for Big Bang?
Evidence of Big Bang, I already told it that there is an expansion, and the expansion is caused due to some reason. The main is the cosmic microwave background radiation that we detected actually, because if there is an explosion, there is a loss of thermal energy, and over a period of time, it will be along with the thing. So this entire universe is permitted by that one, and that's what they discovered it actually.
Sir, this is another question. Could our fine-tuned universe have been created from a single fine-tuned quantum particle?
Fine-tuned quantum particle? I don't get the question actually, but I will try to answer it. Big Bang theory will say the universe which we are talking about, such a huge object, it's the size of the atom. Size of the atom. What is the size of the atom? If you can take your hair and you can see in front of your eyes. So the thickness of that one, you can without any astronomical object, any lens and other thing, you can see it, right? So that thickness means there are 10 to the power 6 atoms are sitting on that. This much is small the atom. So in the time of Big Bang, the size of the atom. What we are doing, we are trying to make the story back actually. We have current observation, which is something happened some thousand, and this is why, because light takes so much time. So you can see what happened some 5,000 years ago. But there will be a light, and that's why you are able to probe it and make your cure. There is a concrete examples for it. What next?
Next question. Will the new generations of astronomical instruments ever reach the farthest corners of the universe.
Yes.
What is possibly beyond the known universe?
First of all, if you are able to find the boundary itself, a big achievement, because universe where it is ending, we don't know. But right now we have features. Just recently, one called James Webb Space Telescope. You are not telescope on the Earth. You are putting in the sky, and you are able to see it. So some latest picture is coming. This year. This year it launched it, and we are able to find it what extent we are going. And finding a universe, there are theories which say there is a multi-universe and other things. But as far as if you ask my point of view, to reaching up to the outreach of that universe, our itself, it's a big task itself. So hopefully people are doing. And important part, if you want a correct thing, is anybody ask about dark matter or dark energy? No?
No, sir. No.
This is the fact that people have to do the research, because we are talking only the 5% of the universe. So basic better question is, can we able to detect the dark matter and dark energy? Then you can able to understand how big the object is. It is not detectable so far, but there are techniques people develop, and one of them is the gravitational force. Dark matter and have only features which have gravity. It will interact via gravity. So instead of seeing beyond the universe, first we have to find the complete picture of the universe. And what we are talking and whatever we I show, which is visible and detectable, it's only 5%. So rest of the 95% we have to detect. Then only we can say we have a picture of the universe. This is a hypothetical, it's a theory with some evidence is there. The next generation or current generation task, and this is going to be not 1-2 year, next 30 years of research, is the gravitational force. To detect the dark matter first. To give an idea, then you can. It's a golden time from the astronomy point of view, because theories are there, you have to test it. And you need engineers, you need scientists, you need cosmologists. So this is the task of new generation. You can see. Anything else?
Sir, how much big is the galaxy? It's infinite.
Galaxy, if you talk about our Milky Way, so in Milky Way, we talk about the distance in terms of the light years, because this is a common unit. Although astronomical, there are another units are there. So if you can roughly estimate, if you're going from one corner of Milky Way to the other corner, it takes 10 to the power 5 light years. And light years means in a 1 second, how much distance is taken. So distance is 3 into 10 to the power 8 meter. 8 meter means the entire India, you can cover it in one shot. So 8.5 minutes or something like that, you take it. So multiply by that number, it is something 10 to the power 13 meter, roughly 3 into 13 meter. And 13 meter, it's a big number actually. Light which take 8.5 minutes to come from the sun to us, if it take 10 to the power 5 years, meaning is nobody's light one corner reach to you. This is all estimated numbers.
Okay, sir, next question is, what is beyond the universe or the multiverse?
This is all hypothetical, and as a physicist, I am not going with a hypothesis idea. Yes, there are theories, and theory is incomplete if you not talk about the observational and experimental ideas, especially observational. So as of now, if you ask my point of view, I think detection of dark matter and dark energy is the key idea to get how the universe is expanding and fast. Multi-universe theory is there, but the detection part, it's very difficult. Because if you have to do it, that one, you have to go to the time of 10 to the power minus 43 seconds to deal with that particular time where your existing physics not able to answer.
So, sir, maybe this one is a good one, sir. If the universe is expanding, does that mean the distance between the planets are also increasing?
Planet is a very small. If you talk about our solar system, we are a very small item. In the starting itself, I told, if you make the universe size of the Earth, The size of the sun is equal to the dust particle and solar system around that size. So just imagine if the earth is building, how much that small dust particle will expand. Expansion may be there, but it is not that rapid that you can feel it. Distance remain the same, and distance also you have to understand it's an angular distance. It's not like that you take an inch tape in a board and you put it and say this is like that. Sun is moving, earth is moving, moon is moving, and there nothing in between on top. So they are keep on moving. So in the plane you have to find their distance. It's an angular distance.
Sir, another question: in what are the ways in which the universe can end? What are the ways in which the universe can end? Universe can end.
Can
what
end.
Are, yeah.
I not understand the question. What it?
Maybe that's a relevant question. Okay.
No, maybe English is wrong, but inbuilt means or something. Maybe can the person will explain it then. Sorry, I not get what question he or she want to ask.
Okay, sir. Let's move to the next one. Can we say the Big Bang? Can we say the Big Bang to be process of expansion instead of saying it is an explosion? Since it was mentioned to describe.
That is still an open question. Big Bang happened. That's why you have a radiation. So some kind of explosion happened. But who and why triggered that? And before that is something is there. That's why I told you that big crush theory is there, big crunch actually. That universe is there and then it will die, it becoming a Big Bang and then another universe is formed. So it's still an open question. This is for this generation to find it. But yeah, many information you can collect it and you can trace it back to. So expansion is important. Say for example, if there will be gravity is attractive force. And if something moving away, you need a repulsion kind of. And repulsion happens when there is an explosion. That's why they give it the idea. Later on, people find it a new form of energy. That's why they call it dark energy, which is responsible to accelerating the object which is far from it. It's a common basic idea. You can do the experiment. Something you are pulling back and something is moving away. So you need something extra which you not seen it. That is what the meaning is.
Okay, then the last and final one, sir. Can we actually consider the time has a fourth dimension because it is already present in the other dimensions as well?
Yeah, so I think what you are trying to say right now, we're not talking about time as a parameter, we will think, and the space thing you study over a period of time. But Einstein theory is based on that idea that it is called a space-time. Time also get changed. So time is a fourth parameter instead of 3 plus 1, it is a 4 actually. And because it's a technical one, so I not go into that. So general theory of relativity, which is the theory of gravity, it is based on that when you consider that time also gets slowed down and the many things are there.
Sir, this one last question also. Sir, does law of conservation of mass energy is valid for the dark energy?
I told you we have no way to see it, whether this kind of mechanism work. Whatever the theory we have, we can explain the visible matter. Yes, we can take as a what is called the first reference point, but we have no idea whether the dark energy means, say for example, atom get de-excited when you give you the radiation. It will work for visible matter. The dark matter or dark energy, it is a question of search. People have to look at it. But energy remain conserved, that is true. There's no doubt about it. That's why people trying to understand another singularity, which is called black hole. So if you can understand some kind of black hole, it may be a kind of an idea you get it on dark.
Okay, thank you, Bharat sir. Let's call it a day. Thank you, sir.
Thank you.
So students, this video will available in our past webinar sessions. Thank you all for joining us today.